Welcome to Eureka Math. I'm Mr. Schenkel. I'm going to be helping you today with the Module 4B review. Let's get started. All right, so the first question that you had today on your review is, what does it mean to isolate the variable? Well, to isolate the variable just means to get it alone, and we had a video that we said should be your theme song for isolating the variable, called Alone by Heart. Some of you thought it was old. In fact, someone asked if these people were still alive, and although it hurt me deeply as an older American, yes, they are alive. But to get the variable alone, that's what we're trying to do. That's what it means to isolate the variable. Okay, explain the steps involved in solving an equation. When you solve the equation, there are a few things that we talked about. The goal, first of all, is to isolate the variable. So that's our goal. And then we had a couple of rules, and we said that the first rule is to undo. So we got rule number one is to undo operations with opposite operations. So if there's addition happening, you undo it with subtraction. If there's subtraction happening, you undo it with addition. If there's multiplication happening, you undo it with division. If there's division happening, you undo it with multiplication. Rule number two was to balance the equation. So there's our steps involved. Once you get the variable all by itself, it has no chance other than to tell you what it represents. And then number three, let me get this out of the way. Number three, we'll explain what the solution x is greater than 8 represents. Well, that just means that every number bigger than 8 is a solution. Every number bigger than 8. So if I graph this, I would say if that's 8, and we had 9 here, and this is a 7, and so forth, then every number bigger than 8 would be not 8 itself, so we exclude it, but everything to the right side, everything bigger is to the right. So every number greater than 8 would be a solution. All right, next. Number one, we have to circle the values of the variable from the given set that make the equation or inequality true. So 2x plus 1 equals 7. There's only one answer since it's an equation, and we have to figure out what that is. Well, 2 times 3 is 6. 6 plus 1 is 7. So the first one is 3. If x is 3, it makes it true. The second one, let's see, we've got maybe 2 times 6 is 12. 12 plus 3 is 15. So let's see, this would have to be a 6, but there is no solution in there. So there's nothing here. None of those make it true. 5 would make 13. 8 would make 16 plus 3 is 19. What we're looking for is a 6, and there is none. So there is no answer to that one. Let's see, 3 times 8 is 24, and then plus 2 is 26, so 8 goes there. If we substitute, let's see, if we substitute a 5, that's 25 plus 6 is 31, so it looks like 5 is the answer here. 3 times something plus 8 equals 8. Well, that would have to be a 0. 3 times 0 is 0, plus 8 is 8. And then 5 times what is 40? Well, 5 times 8 is 40. So there's our equations. Next, give 3 possible solutions to the given inequality. Well, my x is greater than or equal to 2, so anything greater than or equal to 2? I could say 2, I could say 5, I could say an 8, anything bigger, any of those would work. W is less than 5. It couldn't be 5, but it could be 4 or 3 or 2 or 1, etc. Or negative numbers would work. F is greater than 0, not 0, but everything bigger, so 1, 2, 3, that would work. And then this is where we want to read from the variable, the y, and read this way. It says y is greater than or equal to 8. Anything that's greater than or equal to 8 would work. So 8 would work, 8.5, that would work, 9, 10, 12, 20. All right, get the idea. Next, solve the equations for the given variable. You have to show your work. This is where I'm asking you to show me the algebra steps. I want to isolate the x, so I'm going to undo addition with subtraction. So let me rewrite this here. X plus 17 equals 25. I'm going to undo the addition with subtraction. That's a 1. I'll rewrite it. 17. And then whatever I do to one side, I have to do to the other side. The 17s cancel. I get x equals 25 minus 17 is 8. For number 2, let's see, we've got y minus 11 equals 40. So I'm going to undo subtraction with addition. And whatever I do to one side, I have to do to the other side. And the 11s cancel. I get y is equal to 51 for that one. And the last one here is k minus 33 equals 66. Undo subtraction with addition. Whatever I do to one side, I have to do to the other side. And the 33's cancel. I get k equals 99. There's those three. Remember, with algebra, you can always check your answers. You could plug the answer to your variable back into the original equation and see if it's true. So you can do that on your test on Wednesday. All right, this one we have, let's see, 4 times k is equal to 244. Undo multiplication with division. Okay, and then I can cancel the 4's. I get k is equal to 244 divided by 4, I believe is 61. K would be 61. Let's see the next one, number 5. We have 5s equals 125. Undo multiplication with division. And whatever to do one side, I have to do the other side. I get s equals 125 divided by 5 is 25, so s equals 25. And then the last one is well, p divided by 6. I could write this as 1/6 p equals 13, and then I would normally divide by the fraction, but I can't divide by a fraction because that's not defined. So I'm going to multiply by reciprocal, and whatever I do to one side, I have to do to the other side. And when I do this, the 6's cancel, the 1's cancel. I get p all by itself, and then 13 times 6 is 78. 78 divided by 1, 78. All right, moving on. This is where we have to write an equation, and then we're going to solve the equation. So Kelly bought 5 shirts that each cost the same amount. She spent $35.75. How much did she spend on each shirt? Well, 5 shirts, and I don't know how much she spent, so I'm going to call that X. I'm sorry, I don't know how much each shirt costs. So 5 shirts at some cost I don't know. When you add it all up, it's going to be $35.75. And then in order to find the answer, I would have to divide each side by 5. And I would get X equals $35.75 divided by 5 is $7.15, I believe, if that's correct. I believe it is. X is $7.15. That means every shirt is $7.15. Okay, next one. Lexi's selling boxes of cookies. The cost of one box of cookies is $3. She sold enough boxes to earn $174. $3 times the number of boxes, which I don't know, is equal to $174. And then in order to solve this, divide each side by 3, and we would get x is equal to, well, let's see, 50-something, 58, I think, 58. You check that out. If that's not right, you can fix it. I believe it's 58. X equals 58. 174 divided by 3. All right, number 9. Let's see. Let me get a new color here. Brendan scored 32 goals in his hockey games in January and February. If he scored 18 goals in February, how many did he score in January? Well, I don't know how many he scored in January, so I'll call that J. Plus he scored 18 in February, and altogether he scored 32. So if I add those together, I would get 32 January plus February. And then to solve it, I would just undo addition with subtraction. Whatever I do to one side, I'd have to do to the other side, and I would get J is equal to 14 goals. He would score 14 goals in January. All right, last one here. Nick had 26 papers on his desk. His teacher gave him some more, and now he has 100. So he had 26. His teacher gave him some more, so that's a variable. I'll call it X. Altogether, he has 100 papers, and in order to undo the positive 26 here, I would subtract 26 from both sides, and when I do that, I get the 26 cancel, and I get X is equal to 100 minus 26 is 74. So there's 7 through 10. Moving on, we have to write an equation from the table. So a little tougher because they don't give us the actual story, but I do know that every equation starts with the dependent variable equals. So remember, the dependent variable is the second. I missed on my arrow. The dependent variable is the second column. So the dependent variable is my y. So it's definitely y is equal to something. And then I noticed that if I just multiply by 4, 3 times 4 is 12, 5 times 4 is 20, 8 times 4 is 32, 9 times 4 is 36. So if I just multiply my x value by 4, I get the y value. So y is equal to 4 times x. All right. For number 2 here, let's take a look at this one. Well, again, I know it's going to be y equals something. And let's see. If I multiply by 4, I get 1 times 4 is 4. 2 times 4 is 8, not 5. So I can't just multiply here. Looks like I just add 3 every time. So if I back this up, I can see that my y value is equal to whatever my x value is plus 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7. So every time I just add 3 to x, so it's y equals x plus 3. That's my equation for number 2. Sorry about the formatting. That kind of is a little funny looking on here. All right, next we have to identify the independent and dependent variables. Well, it's in a table form, so I know that the boxes of baseballs is the independent. This one's the independent variable because it's in the first column, and the dependent variable would be the total cost. And that makes sense because I would say that the total cost depends on how many boxes of baseballs I buy. And the number of boxes of baseballs that I buy determines my total cost. So I would say that's it right there. And then we also have to write an equation. So let's see, it looks like I can multiply 3 times 20 is 60. 7 times 20 is 140. 10 times 20 is 200. So 12 times 20 is also 240. So I can write the equation. My total cost, we'll call it C. My total cost is equal to 20 times the number of boxes, and we call that B. So the number of boxes, 20 times the number of boxes is equal to my total cost. All right, and then I believe this is, let's see, we've got a couple more here. Write an equation that describes the relationship of the data in the table. Again, I've got to figure out how does the X turn into the Y. So I definitely know my equation is going to start with Y equals. Y equals, well, let's see, I can't multiply, it doesn't look like, because 3 times 2 is 6, 3 times 3 is 9. So nothing works there. But I do see this. I do see that I change by 1 on my X value, and my Y value changes by 2. So this is a plus 2. This is a plus 1. And if that's the case, then I know my coefficient is a 2. So I'm going to say Y equals 2X. And then if I multiply X by 2, I get 6. In order to make it a 7, I'd have to add one more. So I think it's Y equals 2X plus 1. And I would just have to check this to be sure. So if I put a 4 in for X, if I put a 4 in there, I would get Y equals 2 times 4 is 8 plus 1, which is 9, and that's what it's supposed to be. And if I try that again, let's say I put a 6 in there, a 6 in for X, I would get Y equals 2 times 6 is 12 plus 1, which is 13, and that's what it's supposed to be. So this equation does work for my table. All right, and lastly, we have this situation. Mitchell is going to an amusement park over spring break. He found out that the park charges $15 for admission and an additional $2 per ride. We have to write an equation to demonstrate the relationship of the number of rides and the total cost. So those are my variables, the number of rides and the total cost to go into the park. I just have to decide which one's independent and which one's dependent. And we talked in class that total cost is almost always the dependent variable, and it is the case here. The total cost depends on how many rides that Mitchell goes on. So the independent variable is going to be the number of rides, and the dependent variable is the cost, the total cost. So there's our independent and dependent variables. If we said that X is our number of rides, the independent variable, and Y is our total cost, the dependent variable, then if he rode 0 rides, well, it would be $0 times 2 plus the $15 admission, so 15. And I can write an equation here, which will be the total cost is equal to $2 times every ride plus the $15 admission. So there's my equation, and then I can fill out the table from there. If he rides 1 ride, I'd put a 1 into the equation for X, and if I put a 1 in there, it's 2 times 1 is 2 plus 15 is 17. And if I put a 2 in, it's 2 times 2 is 4 plus 15 is 19, and you can see that every time I add a ride, I'm going to add $2 to my total. So it would look like that. The last part, which I didn't do a screenshot of, is your table, your graph of the table, and you have to remember that if this was the coordinate plane, the x-axis would be where your independent variable goes, and the y-axis, which is the vertical, would be where your dependent variable goes, and we'll be checking that on the test on Wednesday. Okay, hope that helped. Remember, the test is Wednesday. We'll review some more tomorrow. See you then.